Hello and welcome back to another session on data structures and algorithms. So in this particular session, we'll be solving one problem based on matrix. And this problem is actually asked in Amazon coding interview. So what exactly is the question? So you are given a 2D matrix. So all that you need to do is find the median of that particular matrix. But there are certain properties that they have told about this matrix. One such property is the number of elements present in this matrix is odd. So what you can conclude is the number of rows and the number of columns will definitely be odd. Next, the other property of this particular matrix is the elements present in every row is actually sorted. So if you observe the first row, all the elements is sorted in the first row. All the elements in the second row is also sorted. All the elements in the third row is also sorted. So all that you need to do now is find the median of this particular matrix. So I hope the question is completely clear to you guys. I would expect you guys to think about the logic, write down the logic, convert that into code and then execute. You might find some error, you might find in certain cases it may not work out. So debug that particular problem and come up with the solution. In case if you are not able to do all of these things, only then continue watching this particular video. I hope you are capable of thinking of some logic and implementing those things. In case if you are not able to think of any logic, do not worry, now I will be explaining you one simple brute force way of solving this particular problem. Before I solve this particular problem, I hope everyone knows what a median is. In case if you don't know what a median is, it's very simple. For example, if there are 3 elements given to you and if these are the 3 different elements and if they are arranged in the sorted order, the element that you find in the between or exactly in the center is considered to be median. This is some mathematical concept which you would have studied in 5th standard. So now coming back to the problem. So you are actually given one matrix like this. Now how can you solve this if you ask? Since it is a 2-dimensional matrix, it might be hard for you to find the element present exactly at the center and the whole matrix is not sorted, only the rows are sorted. So directly you can't come to the center and find. So what is that I would do now is, I will copy all these elements into a new array and that array will be 1-dimension array. So matrix is stored in 2-dimension array. So the new array that I am creating will be 1-dimension array. So how can I create a new 1-dimension array? Very simple. I need to know the size. The size of that particular array or the list will be equal to the number of elements. Now how do I find the number of elements? Simple math again. The number of rows into the number of columns will actually give you the number of elements. So in this case, there is 3 rows and 5 columns. 3 into 5 is nothing but 15. So there are 15 elements if you count. Now I will create a new array of size 15 over here and I am naming it as AR. Now all that I need to do is copy all the elements from here to here. How do I copy? Just traverse these elements and copy all those elements to here. Once I have copied all the elements from matrix to this new 1-dimension array, all that I need to do is, I need to apply sorting on this particular array. And if I apply sorting, this is the resultant array that I will be getting. Now, I know very well, median is an element which is there exactly at the center. So since there are actually 15 elements over here, the element which is there in the center is the 8th element. So it's nothing but the element present in index 7. So the element present at index 7 is nothing but 13. So 13 is actually your element. And how would you find that? Very simple. Whatever is the length of this, length is nothing but 15 of this array. 15 divided by 2 will give you 7. So whichever element is present in 7th index is your median. So this is a brute force way of doing it. I am not going to write code for this. I would expect you guys to write code for this. For what I will be writing code is for a better approach than this. So if you ask me, is there a better approach than this? Yes, there is. But before we see a better approach, let's see what is the time complexity of this particular algorithm. So what exactly I am doing is, if you see, I am creating one new array. So the space complexity has increased. First thing, what is the space complexity? We will see it later. But first let's concentrate on time complexity. So once I create a new array, I have to copy all the elements from here to here. So how many ever elements is present over here? That will be the time complexity. So that's nothing but big O of n. But over here I can't directly say n because they have not told us what is the number of elements. Rather, I have the count of rows and columns. So I can say, instead of n, I can say number of row into column. So n is nothing but row into column in our case. So this to actually copy all the elements from here to here, the time complexity big O of n into c. Now for sorting, if you apply the best sorting algorithm, maybe quick sort or merge sort, this will work as big O of n log n. So n and n should be replaced with what? With what? The number of elements. The number of elements is nothing but n into c. So the time complexity of this particular algorithm is r into c log r into c. That will be the time complexity. And this is the higher order. So what I will do is I will actually eliminate this, and this will be the total complexity of this particular algorithm. And if you see the space complexity, I am creating a new array over here. So the space is also increased. So what is the space complexity in our case? In our case, the space complexity is again log n. Since we don't have n, we need to write in terms of r and c. That's nothing but rows and columns. So it is nothing but big O of r into c is the space complexity. Now I don't want to create any extra space. I don't want any auxiliary space to be created. Without creating auxiliary space, I want some approach which can solve better than this particular complexity. So what is that approach? Just give a thought, then I will explain you step by step. Now let's see how we can efficiently approach for a particular solution. Now I want to show you some observations of finding a median before I show the approach, because without knowing this observation you can't even think about that particular approach. So what's that observation? Observe very carefully. This particular approach is bit complicated, that's why it's asked in Amazon. So I want your 100% focus. In case even if you miss for 10 seconds, you might miss out on the problem completely. So make sure your focus is completely over here. So the first observation that I am going to make is, in case if the array is sorted, this is the array that I have. But actually I won't be sorting it, but I just wanted to show you one observation. So I have sorted for you, but I won't be doing this in the program. What is that I will be doing? I will let you know. Now in this, if you ask me which is the median, I have already marked the median, the element present in the 7th index. So that's the median. The observation is, all the elements towards its left side are smaller than the element which is present in index 7, that's 13. So if you see 13 over here, 13 is the median, and all the elements towards left side of 13 is smaller than 13. And if you see all the elements towards right side of 13, it is greater than 13. So if you ask me how many elements are less than or equal to median element, so median element is nothing but 13. So how many are less than or equal to? So I need to count the elements from 13 to this. So if I start counting, first one is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 elements which are less than and equal to. So all these are less and this is equal to. So what I will do is, the median position I will make it as 8 over here. I am just creating one variable, I am writing median position is equal to 8. Because there are 8 elements which is less than or equal to 8. Now what is that I will do is, I will pick randomly few numbers. First I will pick 1, next I will pick 2, next I will pick 3, next I will pick 4. And every time what I will do is, I will pick 1 and check how many elements are less than or equal to 1 in this. If it is equal to this, then that's my median position. If you have not understood, I will explain you step by step. What I will do is, first I will pick one number 1. Now I will take this number and I will check how many elements are less than or equal to 1 in this particular array. There is only one element. So definitely I know it's not median, because in case if it was median, then the count would have been equal to 8. Since it is not, that's not the median element. Since the number is still smaller, I have to search for some higher number. So I will check for 2. So now if I check how many elements are less than or equal to 2 in this particular array, there are only 2 elements which is less than or equal to 2 in this array. So you know how many elements will be less than or equal to median element in this case, that's nothing but 8. Since you have only 2, this is not the median element. Next I will pick the other number, I will pick 3. I will check how many elements are less than or equal to 3 in this array. There are 3 elements. Is that equal to this number? No, the count is not equal to this number. So that's not the median element. Next I will pick 4. After picking 4, what I will do is I will check how many elements in this particular array is less than or equal to 4, and if you see there are 3 elements lesser and 1 is equal. So totally there are 4 elements less than or equal to 4 in this particular array. Next, you know this is not the median because the count is not matching with this value. Next, what I need to do is I will check with the next number, that's 5. So what I will do is this 5, I will check how many elements are less than or equal to 5 in this particular array. And if you observe, there are actually 5 elements which is less than or equal to 5 in this particular array. So is the count matching with this number? No. So you need to check for some higher number. So I will come over here. Now I will check for 6. So I will check how many elements are less than or equal to 6 in this particular array, and there are 6 elements. So you know very well it is not the median element because the count that I get over here is 6 and the count that I have over here of a median position is 8. So it's not matching. So next what I need to do is I'll check for another number, that's 7. And if I see how many elements are less than or equal to 7 in this case, if you observe there are again only 6 elements which is less than 7. So you know that's also not a median element. Next I will go with 8. Now if you observe how many elements are less than or equal to 8, you know that 8 doesn't exist. But still how many are lesser than or equal to? There are still only 6 elements which is less than or equal to 8. So the count is still 6 and the median position 8, not matching. So you have not found it. Next I will come to 9. I will check, still the number count is still 6. So it is not matching with the median position. Next I will check with 10. Still it doesn't match. Next I will check with 11. Now when I check with 11, there are 7 elements which is actually matching with the condition, that is less than or equal to 11. So there are 7 elements which is less than or equal to 11. But how much do we want? We need 8. Still not matching. So what I need to do? I need to continue this operation. Next what I will do is I will check with 12. If I check with 12 in this case, again there are 7 elements. So still not matching with this. So every time after I find how many elements are less than or equal to, for this definitely I need to traverse this. After that I will check one condition, if the count value is actually less than or equal to this particular, is it equal to median position? It's not. If it is not, I need to continue the operation. Now what I will do is I will check with 13. Now if I check with 13, if you observe in this particular array, there are actually 8 elements which is less than or equal to 13. And what is the median position? 8. So what is your answer? 13 is your answer. So 13 is actually your median. That is what you have to say. So this is the approach. But I know I have not given you the complete solution because in our case we won't have this particular array, but I was showing in this particular array. Now how to do that step by step, I will show you now step by step. So the first thing that I need to show you over here is, if you observe, I picked one element from here. I started with 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8. I kept on checking for different values. Means basically I picked that number and checked how many are less than or equal to. So if you observe, first I checked with 1, then 2, then 3, then 4, then 5, then coming on like this. So linearly I am going over here. And one more thing I want to observe over here is, all these numbers that you see is nothing but the numbers which are there in ascending order. I have written down all these numbers in ascending order. And one more thing is, these numbers does not exist over there. They are, this and this is completely different. This I have simply written it over here. Now what is that I would be doing is, I will be actually making use of binary search. So if you had actually seen the problems on binary search, where you are actually in wood cutting problem or any such kind of problems, the exact same kind of algorithm is what we will be using over here, but over here we are using on 2-dimension array. Now how is that? Let me explain. Now instead of linearly going over here, I will do binary search on these elements. So over here I was checking how many elements are less than or equal to 1, then less than or equal to 2, then less than or equal to 3, then less than or equal to 4, then less than or equal to 5, and somewhere when you reached over here you got 30. You got the answer. Rather than doing like that, what I will do is I will pick one as high, one as low, and I will find the mid and I will check how many elements are less than or equal to this mid element. So according to the binary search condition, whether it's lesser or greater, I will have to change the high and the low in this particular case. So I now basically I need to apply binary search for this. So only that logical part is what I will be showing you over here. So what I will do is I just need two values, that is the minimum value and the maximum value, and those are nothing but low and high. So if I have to do binary search, I need low and high. How to find low and high, I will let you know later on. So basically in this particular matrix, I need to find min, I need to find max. So that's the first step. So I'll find min and I'll find max. Once I have done with finding min and max, the next step I need to do is, if I have to apply that algorithm whichever I explained, I need to know the mid position. Now how to find the mid position? Very simple. In this particular case, this is nothing but the sorted array of this. So in this case, I need to get the answer as 8 because there are 8 elements which is less than or equal to median. How can I get that? Very simple. It's nothing but the element which is there in center, and if you want the element present in center, you just have to do n by 2. But you know, you don't have n value over here. So what is n value? N value is nothing but the number of elements. So how can you get the number of elements? Row count into column count is the number of elements. So R into C is what will give you number of elements. So in this case R is 3, C is 5, 3 into 5 is nothing but 50. So 15 divided by 2, I will actually get 7. But I don't want 7, rather I want 8. Now how can I get that? So R into C gives me 15, I will do plus 1 to it. So row into column plus 1 is nothing but 16. Divided by 2 is nothing but 8, and that's how we get 8. So how do I find the value of median position? Very simple. Median position is equal to R into C plus 1 divided by 2. You find the median position. You found the median position. Now all that you need to do is apply binary search on all of these elements and then check whichever matches with the median, whichever count matches with the median position, that's your element. So if you want to do binary search, you need one while loop. So I'll just write while. Next, what is the condition that I will be writing? What is the condition you will be writing is low is less than high. So basically that is what I will be doing over here. Instead of writing low is less than high, I will write min is less than max, because min is my low, max is my high. Now over here I will simply write one text saying count the number of elements less than or equal to median position. Now before this what I need to do is I need to find the mid. So mid value you already know how you can find. It's nothing but min plus max divided by 2. So I will create one variable mid over here and I will say mid is equal to min plus max divided by 2. Now what I need to do is count how many elements are less than or equal to mid, and if the number of elements matches with that particular median position, then that's your median. So I hope whatever I am going to do is clear to you guys, but how to find the count I will not explain now. I will write a separate method and explain it to later. So basically what I will do is I will just write find count over here. Count is equal to, I will call one method find count. That will find the count for us. Now once you get the count, what is the condition that we need to do in binary searches? I need to check if the count value is less than the median position. So basically in case if this is min and this is max, and if the count value is actually less than the median position, then you know you are somewhere on this side. So if you are somewhere on this side, what you have to do? You have to change your min from here to mid plus 1. So that's what exactly I will do. If I will check one condition is count is less than mid position. It's same binary search algorithm that I am writing over here. So what I will do is I will take this min and I will say mid plus 1 in that case. Or else what is the possibility? Or else the possibility is, there are two possibilities. Either the count value is equal to median position, or the count value is greater than the median position. If the count value is greater than the median position, I know the count is somewhere over here. If it is somewhere over here, I need to come towards this side. If I have to come towards this side, I need to bring the max over here. Now how do I bring the max over here? Very simple. In this else will actually take care of less than as well as equal to as well. So what I will do is, in else part I will say I will bring the max to mid value. Now if I completely follow this particular approach of finding count, and then once I come out of this, whatever value will be present in the min will be your median value, and that's how this search will work. So what exactly happens is, when will you come out of this? Whenever the min value is actually greater than or equal to the max value, you will come out of this. So when you come out of this, whatever is there in your min variable, that is your value, and that's your median. Now I do know you would have not understood you would have understood the algorithm, but not the complete logic behind this particular thing, because over here I told find count, but I am not finding count in this, I am finding count in this. How to do that, I will explain you now step by step. Apart from that, I hope all of the other things are clear. One more thing I need to find is finding minimum and maximum, which is very easy. So now we will see how to find minimum and maximum and how to find the count of this particular elements. I hope till here it's completely clear to you guys. In case if it's not clear, I would request you to go back and again rewatch this particular algorithm. To find the min and max, we need to do one observation in this particular array. So in this matrix, or this is nothing but a two-dimensional array. So in this, if you observe, I told you that all the elements present in one particular row is sorted. In the sense, if I observe only on the first row, all the elements in the first row is sorted. All the elements in the second row is also sorted. All the elements in the third row is also sorted. But the whole as a matrix is not sorted, but every row is sorted over here. So one thing that I can say is, in this whole row, this 5 is the smallest element. In the second row, 1 is the smallest element, and in the third row, 13 is the smallest element. So since this is the smallest element, I know it very well, I don't have to compare these elements. In this row, I know 1 is smallest element, I don't have to check all of the other elements. Since I know this is the smallest element, I don't have to check all the other elements. So the min is definitely among these elements, either 5 or 1 or 13. So what I need to do is, instead of traversing the complete matrix, I will traverse only this particular column, the first column, and all the elements present in the first column I will check whichever is highest or not. So sorry, not highest, whichever is lowest, I mean to say whichever is minimum. So minimum will definitely exist in this particular row. So how do I traverse this? Very simple. So first what I will do is, if I want 5, how can I fetch that? Matrix of 0, 0, because it has 2 index. Next, if I want 1, how do I fetch 1? I just have to say matrix of 1 and 0. Next, if I want 13, how do I fetch 13? Very simple. I need to say matrix of 2 and 0. Now if you observe, this column index remains constant, but the row index keeps on changing. So basically I need to write one for loop which will take care of row index, and it needs to keep on changing. And I already hope that you already know how you can find min and max. So first I will create two variables, min, where min value at starting I will consider this to be the minimum value, that is 0, 0, and max also I will consider as 0, 0. How to find max, we will see that later on. Now first let us focus on how to find min. Now I will write one for loop. Now in this for loop only the row index has to change. So if row index has to change, the value of I should go from 0 till here. So how can I do that? Very simple. I will start from 0 to length of matrix. So length of matrix will give me as 3. So it will traverse from 0, 1 and 2. I hope that's clear to you. Next, what is that I need to do? Every time I need to check one condition. If the element that I am present at, is that already less than the matrix, minimum element. If it is less there, then I need to update the minimum. So I will check that condition. If condition is true, I will say min is equal to matrix of I and 0. So if you observe, 0 is nothing but constant. So I am using constant in the column index, because if you can clearly observe, the column index are 0 completely. So if I write this particular loop, and once I come out of loop, whatever is there in your minimum value, that is the minimum value in this particular matrix. Since you already know how to find min, finding max is very easy. All that you need to do to find max is, instead of checking in these rows, you need to, in these elements, you have to compare these elements. That's the last column is what you have to compare. Why last column? Because you know the last element in every row is the largest element in that particular row. So this is the largest in this row, this is the largest in this row, this is the largest in this row. Now all that you have to do is compare the largest element of all the rows. Whichever is larger, that's your max in the complete matrix. So I have already created one variable max. Now again, if you observe, if I want 45, how can I get 45? That's nothing but matrix of 0 and 4. So I will say 0 and 4. Next, if I want 6, how can I get 6? Matrix of 1 and 4. So 1 and 4. Next, if I want 21, I need to say matrix of 2 and 4. Now if you observe, again over here, the 4 remains constant throughout, but only the value of this changes. That is 0, 1, 2, 3. That's a row index changes, column index is constant. Now the column index, you can't directly write 4 because in this particular matrix there were actually 4 elements or 5 columns. That's why you got 4. In case if the columns varies, for example if they are 10, then the last value will vary. So how can I change this? Very simple. Now I need to write this in terms on number of columns. So how do I get number of columns? Very simple. All that I need to do is find the length of any one of this row. So how do I find the length of the row? What I would need to do to find the length of the row is, ಅದು ಕಟ್ ಮಾಡೋಕ್ಕಾಗುತ್ತಾ? ಅದು ಬರ್ದಿಟ್ಕೊಳ್ಳಿ. Okay. Now, how can I find the length of the row? Very simple. I need to say length of matrix of 0. So length of matrix of 0 means it will take this one row, that's nothing but one dimension array. Now you get the length of this, and the length of this would give you 5, minus 1 is 4. So this way you can actually write it for any row. So you are writing in a generic way. So instead of 4, what I need to say is, I need to say length of matrix of 0 minus 1. So this is how you can find this particular, you can actually get the last column. Now what I need to do is, I need to write one for loop same as the above. For I starts from 0 and goes to the last index in the row 0, 1 and 2. So length of matrix. Next I need to say, if matrix of I comma the last column, that's something but length of matrix of 0 minus 1, if that is actually greater than the max value. If it is greater than the max value, I need to replace the max value. So over here I will say max is equal to matrix of I and length of matrix of A of I. I hope finding min and finding max is completely clear to you guys. Now only part that is left out for us is actually how to find or how to count the number of elements which is less than or equal to the mid value. So how to do that? We will see that now. Now to find actually the count of all of these elements, I will follow one certain logic. But whichever logic I am following now is not actually an efficient logic. Whatever is the efficient logic, I will explain after this. So first, let's see a brute force way of counting all these elements. So how do I do this? Very simple. All that I need to do is, first I need to find the count of all the elements which are less than or equal to mid in this row. Next I need to find the count of all the elements which is less than or equal to mid in this row. Next I need to find the count of all the elements which is less than or equal to mid in this row. Now whatever count I get in all of these rows, I need to put them together. I need to sum all of them and then I need to say what is the count. And later on I will check is the count value less than or equal to median position, whichever I explained you earlier. So now coming to this part. So since I need to count, I need one variable count. So I will take one variable count is equal to 0. Next, I need to first check in this row, then I need to check in this row, then I need to check in this row. So I need to check, traverse every row over here. Since I have to traverse every row over here, definitely I need one loop to traverse these rows. So I will create one loop. So for what I will do is, I will start the value of I from 0 and go all the way till the last row. So the last row if I need to say length of matrix, so I will write that. Now to find the count, I will explain it later on, but now I will call a method called as find count. Find count, what will I pass is, first time I will pass this particular array, means this particular row alone I will pass. So that row is just one dimension array. Along with that, I will pass one more value, that is nothing but mid. Now since I am passing, in the first case I will pass matrix of 0, in the first, so matrix of 0 will give you 5, 11, 20, 35 and 45. Next time I'll pass matrix of 1, next time I'll pass matrix of 2. So basically what you're passing is, to the find count function you are passing matrix of I. Then later on, one more thing that what you are passing is the mid value, so that you know how many elements are less than or equal to the mid value in that particular row. So this function will actually return you one value, and what is the value it's returning? The count of values which is less than or equal to mid. So that I will store in X. Now what you have in X is the value of elements, the number of elements present which is less than or equal to mid in only that particular row. But you are finding for all the rows. So I need to update the value of count. So whatever value of X I have got, I will actually add it to count. So I will say whatever was the previous value of count plus the X value. So that over there you will get the actual value of count. So once, what basically this loop will do now is, first time it will pass this row, you will get the count, it will store in X. You will update that in count. So in this case, let's assume the mid value is 12. So in this case, how many elements are less than 12? There are 2 elements less than 12. So in this case, what happens is, it will actually pass you 2. So what is stored in X is 2. Then later on you are saying count is equal to count plus X. So count is nothing but 0 at starting, 0 plus 2 is nothing but 2. So that's your value of count. Next what happens, you will check in the second row. Again inside the loop you will check in the second row. In this row what happens, all the elements are lesser. So what is the actual value? It is nothing but 5. There are 5 elements. So the X value will be X value will be 5. Now what you need to do is, you have to update this with count. So count value is already 2. 2 plus X is 7. So 7 values are actually equal to count. The value of count is 7 now. Next you need to check in this, none of these are actually less than or equal to 12. So in that case what happens is, you will get 0 in this particular case. So the value of X is 0. When you update with count, the count value remains 7 itself. And there are 7 elements in this whole matrix which is less than or equal to 12. So I hope this particular part is completely clear to you guys. This part can be even optimized, but how to optimize I will be explaining you moving further. But now find count I didn't explain you. I will be directly writing the code for find count, because it's a very easy function that which you would have already seen. But still, in case if you do not know, just let's recall that how this can be approached. So in find count, what exactly you are passing is matrix of I and mid. So whenever the value of I is 0, you are passing the first row. So here I have kept my first row. And one more value is mid. Let's assume mid value is 12. Now what is that has to be done is very simple. You need to check how many elements are less than or equal to 12 in this row. So how do you check that? Linearly you can start from 0th index, you check whether the element in 0th index is less than 12. Yes, if it is less, increase the value of count. Next again you check, is the value present in ith index less than 12? Yes, it's less than 12. So increase the value of count. Next again you will come to the next element, check whether the value present over here, that's 20, is it less than 12? No, it's not less than 12. If you know it's not less than 12, there is no need for you to continue. So you can stop your iteration over here itself. Now whatever you have in count, that's 2, that is what you have to return. So 2 is what you will be returning. The same way, however you found out for this particular row and for this mid value, the same way it can be found for any row and any mid value. So I hope this is completely clear to you guys. More on this, while we are writing code, we can see in depth what exactly this is. And by the way, this particular approach, the whole code is optimized, but this part of the code is not optimized. Why? Because you are still comparing all the elements in this particular array. Now how can that be optimized? I will let you know after writing the code for this particular algorithm. So first, now let's go and write some code for this particular algorithm. Now let's write some code for the algorithm that we have already seen. So the first thing that we need to do is, so if you observe over here, already I have created one main method. Inside the main method I have the same elements which I had shown you over here. Now what I would expect is, I don't want you to hard code this, I want you to take the input from the user. I hope you already know how to take input from the user. then I am actually calling one method named as find median, and I am passing the matrix as a parameter, and you can see I have find median over here and it's accepting the matrix as a parameter, and whatever median it finds, it will return it as a integer value. So that's the return type, and it's collected over here and you're printing that. So I don't have to touch the main method is as it is, so I will bring this code down. So this code I will bring completely down. So now I have enough space for me to write the logic for whatever we had already seen. So the first thing that I need to do is I need to find the min and max. So how do I find min and max? Very simple. All that I need to do is I need to create two variables. So as I showed you earlier, I will create two variables over here. So I will create min, and in min I will assign the first element, that is nothing but matrix of 0 and 0. Matrix of 0 and 0, and the same value I will assign it to max as well. So I will just copy this. Yeah, so max is equal to same thing. Fine, just indent it properly. So I will just indent these two properly. Done. Next I will come to next line. Now I need to find the min. This is not my actually minimum value. To find the minimum value, I need to actually traverse this. So I told I need to make use of one for loop. So I will make use of one for loop. So I will say for. So the I value should actually change from 0 till the last row. So I will say int I is equal to 0. Yes. Next semicolon. I is less than length of this matrix. So how do I get that? Matrix dot length. So matrix dot length in this particular case will give me 3. So it works totally fine. Then every time the value of I should increase by 1. So I will say I plus plus. Now I will come inside. Inside what I need to check? I need to check the element present in these rows. So the column index remains constant, and that constant value is nothing but 0, but the row index changes. So that will be 0 at starting, then 1, then 2. That's nothing but the value of I. So I will write one if condition over here. If, yes, over here I will check matrix of, I will put 2 brackets. Yeah. Now over here I will put row index, and over here I will put column index. You know column index is constant, so I will put 0 over here. Row index is changing, so that's nothing but I, and that is what exactly I had written in the algorithm earlier. So I will check if this value is less than min. So I will check if it is less than min. Yeah, I need to replace the min with this matrix of I and 0. So min is equal to matrix of I 0. Now once I come out of this loop, I will actually get the maximum value, sorry, the minimum value. Now I need to find the maximum value as well. So to find the maximum value, I need to just duplicate this same thing and do some minute changes. So I will duplicate the same thing. Yeah, leave one space. Okay. Now even in maximum value, I need to traverse the same rows over here, but I need to go to the column value changes. The column value is nothing but the last column. So loop remains as it is. Now matrix of I and that 0, that it is not 0, that is the last index. How to get the last index? Very simple. I will remove that. So after this I plus plus, I will come to next line. One second. Yeah. Over here I will check how to find the last index. I had told you earlier how to find the last index. First I need the length of any one of these rows. Either it can be this or this or this, because the length of all these rows are same. So I would basically take the first row itself. So the length of first row, how do I get? Matrix, if I say, I will get the whole matrix. So first I will say matrix. Next in matrix of 0 I will say, in square bracket 0. Now when I say matrix of 0, it will always take the first row. That's nothing but one dimension matrix. I want the length of this. How would I get the length of this? Dot length. Yes, this would have given me the length. Now I don't want the length, I want the last index. So you know the last index is always length minus 1, so I will say minus 1. Yeah. Now this whole thing I will cut. Now this, whatever I had cut is your column index, so I will paste it inside this square bracket. So if so this will basically check for all the elements present in the last column. So I hope this is completely clear to you guys. Next what I need to do, I need to check whether it is less than min. No, this is wrong. I need to check whether it is greater than max value, because I am finding the maximum value. So if this one is greater than max value, then you know this is the max. So I need to replace that with max. So what I will do is max is equal to matrix of I comma and whatever I had cut, I had pasted. That's it. So now this loop will find the minimum, this loop will find the maximum. Now I would say you don't have to do write two loops for doing this operation, because if you see the loop over here and the loop over here, both the loops are doing two different operations. One is finding minimum, one is finding maximum. And if you see the way you are iterating, you are starting from 0 and going all the way till matrix dot length. Over here also, starting from 0 and going all the way till matrix dot length. Here you are increasing the value of I by 1, here you are increasing the value of I by 1. Only place you are changing is the if condition. So basically what you can do is, this particular condition whatever is there, you can place it inside this loop itself. So I'll copy this, I'll put it there. So if I do this, now when you are iterating to this particular loop, what exactly happens is, this will take care of finding minimum, this will take care of finding maximum. Once you come out of this, you will easily get both min and max. So I hope this is clear. So I don't want this for loop, so I'll remove this one. That's it. Now you have found min and max. Why did you find min and max? Very simple. I found min and max so that I can actually get the low and high. So min is your low, max is your high. Now I need to do that binary search and check how many elements are less than the mid value, and that is what I am going to write now. Now let's apply that binary search to find the actual median. So we already have our min and our max, that's nothing but low and high in our case. So I need to start with while loop, so I'll say while min is greater than max. Min is less than max. And if that condition is true, I need to do some operation. So first let me scroll it up. Okay, great. So over here, first thing I need to do is find the mid value. So how do I find the mid value? I'll say mid is equal to, and I need to say min plus max divided by 2. Min plus max divided by 2. Great. Next, once I come down, now all that I need to do is, in this particular matrix, how many values are less than or equal to mid is what I need to do. So if I have to do that, I need to keep track of the count. So I need one variable count, so I will create that variable. Int count is equal to, I will start from 0. Great. Next, now if I have to find how many values are less than or equal to mid value, I can't do it in one shot. Rather, I need to check for this row first, then this row, then this row. So basically I need to traverse every row one by one in this case. So what I would like to do is, I would like to create one for loop. So I'll say for, yes, the value of I starts from 0. So I'll say int I is equal to 0. Great. Next, this value of I goes all the way till the last row. So it's nothing but matrix dot length. So I is less than matrix dot length. Matrix dot length. Yes. Next, I will increase the value of I by 1. So I will say I plus plus. Now once I come inside, what I will do is, I will not write the logic over here. Rather, I will call the function or the method. So the name of that method is find count. And what will I pass to this method is, I will pass this row or this row or this row. Any one row I will be passing every time. So since I am repeating it multiple times, so let's assume I am passing this row. Along with this row, I need to pass the value of mid. So what I need to do is, I need to call that method find count. Yes, I need to pass matrix. Now if I just say matrix, it means the complete matrix. So I need matrix of either 0 or 1 or 2. So I can say matrix of I over here. So I'll say matrix of I, comma, and after that I need to pass the mid value as well. So I'll pass the mid. Now this function will take care of finding how many values are actually less than and equal to the mid value. And whatever it returns will be that particular count value. So what I will do is, I will store it inside a temporary variable x. So I will say int x is equal to this. Now x knows only the number of values less than or equal to mid value in one single row. So I need to keep track of all the rows. So where I am keeping track, I am keeping track in the count value. So I need to update the count value. How would I do that? So whatever is the value of count, as of now, the first time it will be 0. So I will say count. So 0 plus whatever is the new value, whatever I would have got over here. So I will say count plus, yes, the x value. Whatever I get, that will be the updated value of count. This is what I need to do. I hope this part is completely clear to you guys. Next, once I come out of this loop, basically I would have checked for, basically I would have called this multiple times. So multiple times in the sense, first I will call this, next I will call this, next I will call this. So I'd have basically checked for all of these things. So now I would have the actual value of count. So in count I will have how many elements are lesser than equal to mid value in this particular matrix, and that's what exactly I need. Now what I will do for that is, now I need to check whether the value of count, so I'll check if the value of count, now is this less than the mid position. So I'll check if it is less than mid position, sorry, not mid position, median position, median position, POS you can. Now the problem is, in the algorithm I have found the median position over here, but in this code I have not found the median position. So first let's go and find the median position. So median position you can find at starting itself. I have told you how to find as well, and I have told you the formula for that. So I will go all the way to the top. Yes. So as soon as I find min and max, over there itself I can find the median position. So I'll say int median position is equal to, so it's nothing but row into column within brackets. So row, how can I find the row and how can I find the column? So over here I directly told a row into column, but how do I find the number of rows? That's the problem. How would I find? Very simple. All that I need to say is, if I want the number of rows, I need to say matrix dot length. So that's what I'll say, matrix dot length. So matrix dot length will give you the number of rows. Now how can I find columns? So these are the columns. So 0, 1, 2, 3, 4 is the column values. So basically there are 5 columns. So how can I find this if you ask me? I will pick any one row. Let's pick the first row. If I pick this first row, the number of elements present in this, or the length of the first row, is only my column, is the number of columns that I have. So how would I do that? So I will say into, yes, matrix. If I say matrix, it's saying the complete matrix. I don't want the complete matrix. I want only the 0th row. So what I will do, matrix of 0. So matrix of 0 would basically give me this particular row, this complete row. Now if I get the length of this, it's nothing but 5. So it will say dot length, and that's the number of columns. So basically this is the number of rows and this is the number of columns. So I hope this is clear. So if I do divide by 2 in this case, the length of the, so matrix dot length, so basically the row is nothing but 3 and this is nothing but 5. 3 into 5 is nothing but 15. 15 divided by 2 is nothing but 15 divided by 2 is 7, but I don't want 7, I want 8. So what I will do is, rather than doing 15 divided by 2, I will say 16 divided by 2, I will get 8. So I will say plus 1, now divide by 2. Yes, now I got the median position. Now if the count value is equal to the median position, then definitely I would have found. In case if it is lesser, then I know what is that I need to change. So I will come all the way down. So I am checking, is the value of count less than median position? And if the value of count is less than median position, we know the min value has to be changed. The min is nothing but mid plus 1. So I will say min is equal to mid plus 1. Yes. Now if this is not the case, it means to say either the count value is greater than median position or count value is equal to median position. In case if it is greater and equal, then the high value or the max value has to be changed to mid. So I will say else max is equal to mid. Now I told you, once you come out of this while loop, so I will come out of this while loop, I will remove all these extra lines. Yes. Now once I come out of this while loop, whatever value I will have in min, that would be the actual median value. So what I will do is, I will directly return that. So I will say return median. Yes, sorry, return min. That's it. Now this is completely taken care, but I have not created this find count. So let's go and create this find count. So I will go out of this method. Yes. I will just scroll. Yeah. Let's create that method as well. So I will just say static. And this value is actually returning the count of that particular row. I need to keep the return type as int. So I will say int. Next, after that, the name of the method. So find count. And what it is accepting, it's accepting one dimension array. So I will say int one dimension. So it's single square bracket. I will name it as AR. Yes. and after that what it's accepting is the mid value, so I'll write over here as mid itself, so int mid. You can name it whatever you wish to name it as. Usually people name it as key, so I will come inside over here. Now inside this, all that I need to do is I need to keep track of count. How many elements in this array is less than or equal to this? So if I want the value of count, I need to create one variable count. So I'll create one variable count. Int count is equal to 0. Now I need to traverse this particular array. So if I had to traverse this array, I need to create one for loop. So let me create one for loop. Yes, it starts from 0th index and goes till the last index. So I'll say int I is equal to 0, I is less than ar dot length. Yes, always it has to increase the value of I by 1. Yes, after that I will come inside. Now I need to check, is the value present, whatever value is present in the ith index, is that less than mid value? How do I check? I will put one if condition. So I will say if, I will check ar of I, is that less than mid value? Yes, if that is less than mid value, so what I need to do is I need to increase the value of count, so I will increase the value of count. Count plus plus, yes. Next I will come out of this. Now once I come out of this, basically I would have traversed this complete array. So from this end, so basically I would have having only one row. So I would have traversed from this row to this row. And in case if the value of mid was somewhere around, like let's assume it was 15. So I have checked how many elements in this row is less than 15. That's what the code you have written over here. Now in this particular case, what is the value? It is 2. 2 values are less than 15. So it would have written 2. So that is what you have written. So I'll say return count. Now one thing that you know about this particular array, whatever you are accepting, is this array is sorted. Since this array is sorted, you know if this condition fails, then you know the element is greater. So what I will do is, if element is greater, now for example if I had 15, I would have come here. So now the element is greater. If the element is greater, I know that I don't have to check for this nor this, or if there is any other elements towards that side, I don't have to check for those elements. So I can stop checking this, or I can come out of the loop. So if I have to come out of the loop, I need to break. So when do I break is, I will come to if else part. So I will come to else part and I will break it. Now there is one small mistake that I have done while writing this code. I need to check how many elements are less than and equal to the mid value. But over here I have just written less than, so I need to make it as less than and equal to. This is all the code. So let's see from starting what exactly we have done. So if I scroll it down. So first let's go to main method. So this is my main method. So in this main method, if you observe, I have created one matrix that's nothing but like this. Then I am calling median, and whatever it returns, I am printing. Now if I actually go to find median, yes, I have created, I have found min, I have found max, median, position. I hope this part is completely clear to you. Next, I need to find the low and high. How would I find? By using this. This will take care of finding low, and this will take care of finding high. So low is nothing but the min value, high is nothing but the max value. Next, after that, I will scroll up. This while loop, this is where your actual logic exists. So what you are doing is you are checking if min value is less than max value, and you are finding the mid. Now you are checking how many elements are less than or equal to the count. Less than or equal to the mid value. If that is equal to the position, that is nothing but median position, then you know that is your value. So what I have to do is I need to count all of that. For that I have written a loop, and this is what we wrote just now. So this will take care of counting the number of elements less than and equal to the mid value in the complete array. Now after that I will come down, I will just put one if else condition where I am checking should I change the mid value towards the right side or the left side. Means basically I need to, do I need to increase the mid value or decrease the mid value. So and that's what I am doing. So if I have to increase or decrease the mid value, definitely I need to change either the min value or the max value, or basically in binary search we call as low and high or begin and last, all of these things. And once you come out of this while loop, whatever exists in the min, that will be your median value. So now let's check whether we are getting the median according to what we expected or not. So for checking, so let me just execute this particular problem. So if I just execute this, you are getting 13 over here. And if you see in our matrix, so if I can go to the main method, if you see in this particular matrix, you clearly know this when we sorted and when we found out 13 was the median. So the same logic you can do it for any other values as well. So I would request you to take out this code and check for all the different inputs that is given. Now the problem is, I had told there is a better approach than this particular approach. Now what is the better approach? Very simple. All the code remains as it is. There is one small change is what I need to do. So where exactly I need to change? I will show you over here. So if I go to find median. So I have been to find median. This part of the code can never be changed because this is most efficient way of writing it. Now if I slowly scroll it up, the only one part where I can change is in this part is where I can change. So over here, you know this particular matrix of I, whatever you are doing, that is sorted. But how are you finding the count? You are starting from the starting of the index and going all the way till the end of the index. So basically you are doing a linear search over here. So since it is sorted, rather than doing linear search, I will do binary search. And how is that I am going to do binary search? I want you to first give a thought about it and see what are the changes that can be made, and in case if you are not able to do, then you come and watch the video. I will explain you how exactly to do binary search and change this completely. I hope you thought about optimizing this particular code whichever I showed. So basically, in case I even told you that you can make use of binary search and then optimize. So I have already created binary search over here and I have kept it. I will open and show it to you guys. So now I will make use of binary search and optimize this particular code. So what is that optimization I will be doing? Let's see step by step. So if I go and open the find median. So in this find median, I told you very clearly that I can optimize this part of the code. So basically find count, what it is doing is, if a matrix like this is given, it will do a linear search from this end to that end and check how many elements are less than or equal to the max value. So for example, mid value. So for example, if the mid value is given as 45, it will start from here, it will count 1, then it goes here, 2, then it goes here, 3, then it goes here, 4, then it goes here, 5. So that's how it counts. But if you do binary search, it will come here, next step it will directly go here. So that's how. 2 ops it will be completed. So if the number is a lot more than this, binary search works perfectly, but in linear search it works very slow, and you already know the complexity of linear search and binary search. So now what I will do is, instead of calling find count over here, I will basically make use of another method that's nothing but binary search. So what I will do is, first let me go and show you what is that I have written in binary search. So I will just open that binary search. I am not going to explain this code to you as of now. Why? Because you already know what is this code, and this is the exact same code which you have studied earlier when you were studying about binary search. So now I am just calling this method, and you know what does this method do. For example, if I call and check for 20, if the mid value is passed as 20, then it will check where is this 20 present. So it will return you this particular index. So by making use of index, you can clearly say how many elements are less than or equal to, and how is that I will show you over here. First let me go and do some changes. So I will scroll it up. So over here, instead of find count, I will say binary search. So yeah, binary search. So I think the name over there is mismatching, so you can just go and check it over there. Yeah, correct. Now it's totally fine. So I am calling that binary search. Now what does binary search do is, let's assume I have passed this particular row, and this is nothing but the 0th row which was present in that particular matrix that we had seen. Once I pass this, and if I pass the mid value to be somewhere between somewhere as 20, so it will check where exactly 20 is present. So 20 is present where it is present in index 2. So since it is present in index 2, it will return me 2. Now by making use of this index, I know that there are 3 elements which is less than or equal to 20. So basically I am just adding one value to the index value, that's it. So like this I am making use of binary search. But there is a problem in this particular case. What is that problem if you ask me? Very simple. Problem is something like this. Instead of this particular array, if I had some array something like this, where 20 is repeated multiple times, what does binary search do? It will take this as low, this as high, and it will make this as mid. Now you know, you are checking for what? 20. So is this the element that you are checking for? Yes, this is the element that you are checking for. So it will return you 2. But for us, what do we need? We need to see how many elements are less than or equal to 20. We don't want the index of 20. So in this case, how many values are less than or equal to 20? There is 1 value, 2 value, 3 values, 4 values. There are 4 values which is less than or equal to 20. Even if you do plus 1, you will not get 4. So there might be a possibility even this also might be 20, but still your binary search would have returned this value. Now how can I fix this value? Simple. What I will do is, I will come to this particular index as soon as I finish checking this. So I will come to next line. Now over here what I will do is, I will check if the value present in this particular index, that is nothing but what? Matrix of, and I need this row is nothing but matrix of I. So matrix of I would give me something like this. Now I will check matrix of I, and x value is nothing but this particular index, that's nothing but 2. So I will say x. Now matrix of x and I and x, is that equal to the mid value is what I will check. Is that equal to mid value? So I was actually checking for mid value. Yes, it is equal. In case if it is equal, what I will do is, I will just increase the value of x now. Now while I increase the value of x, now the x value comes over here. Now there might be many more 20s towards that side. If there are many more 20s towards that side, I need to keep on doing this operation till I find the last 20. So what I will do is, again I will come over here and I will check the same value. If that is the case, I need to again increase the value of x. Again what happens? X value will come over here. Now I will check whatever element present in x value, is that actually equal to the mid value. It is not equal to mid value. So your x value will actually stay over here. So where is your x value staying at the end of the day? It's staying in 4. And how many elements are less than or equal to 4 in this case? There are 4 elements, less than or equal to 20 in this case. There are 4 elements which is less than or equal to 20. So basically if you just do that one small change, you are actually getting the value of x. So what I will do is, I will actually cut this code. So this is the condition I need to check. So I will leave some spaces in between. Yeah, over here I will create one loop. So while loop is what I am creating. So while I will check, I will paste that condition. Matrix of I, why I am writing is because I just don't have to check in this particular row. I need to check in all the different rows. So this for loop is taking care of that. Now x value is to take care of this particular things. So x is equal to mid. If that's the case, I need to increase the value of x. So x plus plus. This is all I have to do. This is some extra steps that I have to do, so that by using binary search, I am not mismatching with the result. So the same logic will even help for the previous example as well, and that's nothing but this particular example, where you have 5, 1, 20, 35 and 45. So in this case, if the mid value is 20, let's assume 20. What does binary search result return me? The x value will be 2 in that case. Now I will come and check over here, matrix of I and x. So I and x is nothing but 20. Is that equal to mid? Mid value is what? 20. Is it equal to 20? Yes, the value present over here is equal to 20. What I will do is, I will increase the value of x. So the x value will come over here. Now it will be in 3. Now the value of x is 3. Now all that I need to do is, I will again go and check, since it is while loop. Matrix of I of x. Matrix of I of x is how much? 35. Is 35 equal to mid value? No, condition fails. Condition fails means comes out. So where is your x value? It is 3. Now if I ask how many values are less than or equal to 20. So there are 3 values less than or equal to 20, and the value of x is also 20. That's it. So I hope the problem is clear to you guys. Now this is what exactly you have to do. But when you are doing this particular thing, there might be a probability that you might get one exception. What is that exception? I will show it to you by making some changes in the input moving further. In case if you have already got, that's great. But if you have not got, just wait for a while. I will let you explain what exactly the exception is. Now this problem is taken care. But there is one more problem which arises in binary search. Now if you ask me what exactly is the problem is very simple. The problem is, over here I took the mid value example as 20. Let's assume instead of 20 I had given a value as 15. Will your binary search find 15 over here? Because binary search, what does it return? It returns the index value of the element that you are searching for, but there is no 15 over here. That's a problem. But what are you expecting? You are expecting how many elements are less than or equal to the mid value. Less than or equal to the mid value, and in our case it's 15. So there are 2 elements. But what does your binary search return? It returns -1. So we need to slightly change the binary search according to our requirement. And what is that change? Let me show you step by step. So basically what I will do is, I will close this. For positive value you already got it. So let me close this. Let me go to main method. Yes. Now in main method, let me just comment these 2 lines. Now I will call binary search. So over here I will call binary search. In binary search I need to pass either this matrix or this one or this one. So you know whatever I am showing over here is nothing but your first row which I have represented over here. So how can I get that? Matrix of 0 is what I need to say. So I will say not AR of 0, matrix of 0, because I have named it as matrix. And k value, what I will do is, first let's check for 20. So I will check for 20. Now whatever it returns I will just print it. So basically this binary search should have returned 2 in our case. So I need to print 2. So I will just cut that and I will print it. I will just remove this extra semicolon. Let's execute and see whether it is giving me 2. So if I just execute it, I am getting 2. So there is no problem. Now I will show you the problem. Now what is the problem if you ask me? Instead of 20, if I give 15. Now basically what I wanted to return is, I wanted to return how many elements are less than or equal to, but will it return that or not is the question. So what I will do is, I will just execute and see. So if I execute, it's returning -1. So there is a problem. How to fix? I will let you know. Now let's assume over here I will find for 40. I will change this mid value to be 40. So you can just give one space over here so that there is no confusion, and over here also after this line one space. So I am checking for 40. So let's see what exactly the output is. So 40 also it's saying -1. Now this is a problem. Now I can easily fix this problem by doing one small change. And what is that change? Let me go to binary search. Now over here, always when I don't find the element, what I am doing? I am returning -1. Now instead of -1, I will return something else. Now what is that is left out for me? There is high, there is low, there is mid. What I will return is, I will return low over here. Now if I return low, what does it return? Let's see. So I will not try directly return low, rather I will try return minus low, so that I know that I didn't find that element. So I will say minus low. So minus low, for example, in case if the low value is 2, it will give -2. If the low value is 3, it will give -3. If for 4, it will give -4. It's simple math. So next, I will just close this. Yes, let me execute this. I am finding for 40. So basically what it's saying is, it's saying me -4. Now you see, how many elements are less than or equal to 40 in this particular array? 1, 2, 3, 4. So if I just convert this minus into plus, my problem is solved. But now the problem is, does this work only for 40 or does it work for all the numbers? How do I check this? Very simple. What I will do is, instead of 40, let me check for 15. Yes. So 15 does not exist over here. So what I will do is, let me execute and check what it gives for 15. So it's giving me -2. Now check how many elements are less than or equal to 15 in this. You can clearly see there are 2 elements which is less than or equal to 15. So if I convert this minus into plus, and if I add it to my actual count in that particular method, find median, problem is solved. But I don't know if it works for all the elements. So what I will do is, I already have till 45. So what I will do is, I will make it as 55 instead of 15. Now let's go and execute the program and see what exactly the output we are getting for this. So since there are 5 numbers which are less than 55, we should be expecting minus 5, and we are getting minus 5 over here. So we are successful in getting minus 5 as of now. Now all that I need to do is very simple. Whenever it's a negative value, I just have to convert that into a positive value. Now how do I do that? Very simple. Let me go to find median method. So in find median method, I will just scroll down. So over here we are finding max, min, all of that is fine, and inside the loop over here is what I need to do the change. So binary search I will be calling over here, and I will be storing the value inside a variable x. Now I need to check whether the value of x is it positive or is it negative. Now in case if it is positive, I need to make use of this particular logic, but if it is negative, all I need to do is just convert into a positive number. So what I will do is I will write one if else condition to check whether it is positive or negative. So first let me cut this particular code. I will cut this code. I will say if I need to check if the value of x is positive. How do I check? If the value of x is greater than or equal to 0, so if it is greater than or equal to 0, I know it's positive, so I will paste the code whichever I had copied. Now in else part, if the condition fails, we know it is a negative number, so I will come to else part, and in the else part all I need to do is convert x into a negative value. How do I do that? Sorry, positive value, because I already know x is negative if I come over here. So I will say x is equal to whatever is the value of x into minus 1, or else you can even write it as x is equal to minus x. So minus x is nothing but x into minus 1 itself. Internally that is what it does. So this should give us the expected output. Now let's go and check if we are getting the expected output or not. So what I'd like to do is I'd like to go to the main method. So if I scroll to the main method, so this is the matrix that we have. So what I'll do is I'll just comment this particular line and I'll uncomment these 2 lines to check the median. So if I uncomment these 2 lines and if I execute, let's see if we are getting the expected output as a median or not. So this is a matrix. So if you see we are getting 13 and that's the expected output. Now I'd like you to actually go and test this particular code for different test cases, and over here if you observe I have actually taken this hard coded this matrix, but you should be capable of taking the matrix of your own size, which is m into n. I hope this problem is completely clear to you guys. I would like you to actually not just solve this problem, along with this I want you to go and solve more and more other problems on matrix as well.